We have talked about conic sections, and with each conic section, we have either graphed them vertically or horizontally. Okay? Somebody in one of my classes, I don't think it was this class, asked about, well, can we have an ellipse that's like diagonal? Yes, we can. Okay? We call this a rotation of a conic. All right? So anytime we've had a conic section, we have had an equation that looks like this. Now, if it was a parabola, then either the x squared or the y squared wasn't there, okay? But we've seen x squared terms, y squared terms, x's, y's, and constants, okay? You may not remember, but in the very beginning when I introduced conic sections, I wrote this equation right here, okay? But we've never seen that term with an x and a y. When that xy is present, we are going to have a rotated conic. Okay. When that xy is present, we are going to have a rotated conic. Okay. So we're not going to focus on the graph until later on in the class period, but essentially, we are going to rewrite our equation, and we are going to plot a new xy axis that's been rotated, so then we can plot our conic on that new set of axes, okay? That green set of axes, that's the xy axis but rotated, okay? So you see that our ellipse isn't horizontal or vertical, it's like tilted at like a 45-degree angle. All right, so now we're in a whole new ballgame, okay? We can't just look to see if there's an x squared and a y squared, and are they both positive, then it's an ellipse, okay? Our rules will work only when we have conics that haven't been rotated. But as soon as we introduce this xy term, those rules don't apply anymore. Okay, so we need a new way to determine what kind of conic we have. All right. What do I say? B squared minus 4AC. Have you heard that in something before? What is that part of? The quadratic formula. Do you remember what we call it? It has a name. B squared minus 4AC has a name that starts with a D. Called the discriminant. Okay. Here's our rules for discriminants. Okay, go ahead and write these down, and then we'll talk through them, all right? So what do A, B, and C stand for? If we go back to here, I'll come back. A is the coefficient of x squared, B is the coefficient of xy, and C is the coefficient of y squared. Okay? So when we are determining the type of conic, these don't matter. They will later on, but to determine the type, all we need is the x squared, xy, and y squared term. Okay? So if it's less than 0, we are going to have an ellipse or circle. We won't know which type until we rewrite it. Okay? So you have to write ellipse or circle. Okay? If the discriminant equals 0, we have a parabola, and if the discriminant is positive, we have a hyperbola. Okay? When we're identifying conics, if it is a non-rotated conic, like what we did yesterday, you have to tell me ellipse. If it's an ellipse, circle if it's a circle. With a rotated conic, we don't know, so we have to put ellipse or circle. Okay, we have to put both in. Okay, so let's practice. I have the following conic. 2x squared minus 3xy plus 2y squared minus 2x equals 0. Since the xy term is present, we have to use the discriminant. Okay, so what is our b term? -3. So we have b squared minus 4 times, what is a? 2, because it's the x squared, and what is c? 2. So we have 9 minus 16. Doesn't really matter what it is. How does it compare to 0? Negative, so it's less than 0, which means we have either an ellipse or circle. And you have to write both. Our next one, x squared minus 6xy plus 9y squared minus 2y plus 1 equals 0. The xy term is present, so we have to use the discriminant to determine the type of conic. Okay. So, what is our b value? -6. So b squared minus 4 times, what is a? And what is c? So we have 36 minus 36. How does that compare to 0? It equals 0, so if we look at our rules, that means we have a parabola. Okay. Determine number 3 for me. (3x squared plus 8xy plus 4y squared minus 7 equals 0. Joe, what kind of conic do we have? Hyperbola. So you got your discriminant to be greater than 0? Okay, how many of you agree with Joe? We have a hyperbola. Excellent. Okay. So when we go to actually work through these problems, it's important to know what kind of conic you're working with, okay? Because by the end, you want to know what your standard form needs to look like, right? Probably important, okay? So what are we going to do here? We have this xy term, kind of throwing us for a loop, right? We can't like separate out a term. Okay, it has x and y. We can't just like split it in half. It doesn't work like that. So we're going to need to figure out how. So we figured out what type of conic it is. We need to figure out how much this type of conic has been rotated, and then figure out what the standard form is for that rotation. Okay? So we are going to eliminate the xy term. And once we've eliminated the xy term, that's the conic that we're going to graph on the rotated axis. Okay? So what we're going to do, we're going to be given an equation that looks like this. That's what we've been talking about for the past 15 minutes. And what we're going to do is we're going to change the way our variables look. We're going to write our equation in terms of x primes and y primes. And I'll show you how we're going to do that. But by doing that, we're going to eliminate the xy term. So we have an equation that we're used to seeing like on yesterday's quiz. Okay? So we're taking our equation and we're going to define our variables, which I'll show you how to do here in a little bit. But we're going to write our equation in terms of x primes and y primes. In order to change our variables, really how they look, okay, we're first going to need to know how far we've been rotated. Okay. We're going to rotate our axes by theta counterclockwise, and this is how we're going to determine theta. Okay? I know this is kind of boring right now, but we got to get some of the groundwork laid. Okay? And just like with any other type of problem, we will work through this. Right now it sounds kind of foreign, but once we work through a problem, it will feel better. So counterclockwise, that's the nice way to rotate in math. That's the positive direction, right? I do not care which one of these you use. If you are more comfortable thinking about tangent, you can use tangent of 2 theta equals b over a minus c. If you don't care, cotangent of 2 theta equals a minus c over b. It doesn't matter which one you use, okay? But you got to remember one. Okay, so this is how we are going to determine which angle we're going to rotate our axes. Now, there are going to be lots of angles that satisfy this equation. Do you agree? Because our unit circle repeats over and over and over and over. We are always going to rotate the closest angle counterclockwise. So if we have the tangent is radical 3, okay, then we're going to choose pi over 3, not 4 pi over 3. Okay. So then, with this angle, we are going to redefine our variables, okay? We want to write our equation in terms of x prime and y prime. This is how we're going to do it. Our x is going to become x prime cosine theta minus y prime sine theta. And our y variable is going to become x prime sine theta plus y prime cosine theta. Okay, so let's put on perspective here. We're going to figure out what kind of conic we have to start with. All right. Then we're going to need to figure out what angle this conic has been rotated by. Okay. After we have our angle, we are going to redefine our variables. So we're going to have a binomial for each variable that we then have to plug in, and we're going to have to do a bunch of algebra to rewrite our equation. Okay, we're going to plug in those simplified values into x and y, and we're going to have to do some multiplying and combining like terms, and then putting our equation into standard form. Okay, so you're going to have some patience while you're doing these problems. I've only assigned you 4 because I'm going to take one of those away. Let's, before we begin, remind ourselves about the unit circle. It's been a few days since we've used some tricks. At 0 radians, what is this coordinate right here? 1, 0. And Sean, what is the tangent at 0? 0, which means the cotangent is? Okay. That is a terrible circle, but you guys will forgive me. At pi over 2, what's our coordinate? 0, 1. Sarah, what's the tangent at 0, 1? And what's the cotangent? Great. At pi over 4, what's our coordinate? Great. And Michaela, what would our tangent be? Our tangent would be 1. At pi over 3, what's our coordinate? Excuse me, pi over 6. This is pi over 6. Pi over 6, what's our coordinate? Radical 3 over 2, 1/2. And what's the tangent at pi over 6? Say it louder. I hear it. Radical 3 over 3. And so then at pi over 3, our coordinate is 1/2 radical 3/2. And the tangent of pi over 3 is radical 3. Okay? Just a reminder for you because we're going to need to know those. Okay? So we're going to start off very simple. xy minus 4 equals 0. We have the xy term present, so we know this is going to be a rotated conic. Okay? So first thing, we need to figure out the type of conic. Okay, so we're going to use the discriminant. So b squared minus 4ac. What is our b term? A? Do you see an x squared term there? No, so we're going to put a 0. Do you see a y squared term there? No, so we're going to put a 0. And what kind of number is that? Positive, negative, or 0? Positive. Which means we have a hyperbola. Okay. Now we're going to determine the angle. Okay. How many of you would prefer to use cotangent? How many of you would prefer to use tangent? All right. So the tangent of 2 theta, we decided was b over a minus c. Correct? So we have the tangent of 2 theta, b was 1, a and c were both 0. What is 1 divided by 0? Undefined. So right now we have the tangent of 2 theta is undefined. We talked about where the tangent was undefined. Where was that? Son? Okay, so technically the tangent is undefined at pi over 2 and 3 pi over 2. But which one do I want you to choose? Pi over 2, because it's the closest angle. All right, I want you to stick to the first quadrant, and then if it's negative, if we have a negative, then the second quadrant, but nothing past that. Okay, so our angle is 2 theta. That needs to be pi over 2. I'm using some solving equations with trig here. So what does that mean theta is? Yeah. Pi over 4. Okay, so I'm going to highlight this so we can come back to it. Okay, so our angle of rotation is pi over 4. All right. Which, when we get to the graph, will be kind of nice. All right. Then we get to redefine our variables. Okay. X is x prime cosine theta minus y prime sine theta, right? That's what you have written down. So what we're going to do is we're going to take theta and we're going to put in pi over 4. So our x variable is, what's the cosine of pi over 4 again? So radical 2 over 2 x prime minus, what's the sine of pi over 4? Radical 2 over 2 y prime. I'm going to just highlight this because we're going to have to come back to it. And then y. We redefine y to be x prime sine theta plus y prime cosine theta. So we're going to take theta and we're going to plug in pi over 4 since that is our angle of rotation. All right. So y becomes radical 2 over 2 x prime plus radical 2 over 2 y prime. Okay. This is all just the groundwork. Okay, we haven't even got into the algebra yet. Okay, what are we going to do with this now? We are going to take our x and y, and any x and y that you see in your equation, that's what you're replacing it with. Okay, so we have x times y minus 4 equals 0, right? So x, we will replace it with radical 2 over 2 x prime minus radical 2 over 2 y prime. Our y becomes radical 2 over 2 x prime plus radical 2 over 2 y prime plus minus 4 equals 0. Okay. Now it is a matter of multiplying things out, combining like terms, and then getting it to standard form. Okay, here's where you're going to need to exercise some patience. Please go slow when you're doing this. It is very frustrating to make one little multiplication error and have to go back and redo all of your work. Okay, so take your time and be careful as you multiply. So let's do this. Radical 2 over 2 x prime times radical 2 over 2 x prime. One half. Because radical 2 times radical 2 is 2. 2 over 2 is 4. So we have 1/2. And I'm going to write x prime squared. Because we have x prime times x prime. Okay? You don't have to put the parentheses there. But if you don't, it kind of looks like a 12. And so I don't want you to get confused. So I'm going to write them in parentheses so it doesn't look like x to the 12th power. Okay? Radical 2 over 2 x prime times radical 2 over 2 y prime. Say it.
1/2 x.
Okay. Negative radical 2 over 2 y prime times positive radical 2 over 2 x prime. Good? And then radical 2 over 2 y prime times radical 2 over 2 y prime. We have minus 1/2 y prime squared minus 4 equals 0. The whole point of replacing our x's and y's with those binomials is so that our xy term disappears. What happens here to our xy term? It disappears. So what we are left with is 1/2 x prime squared minus 1/2 y prime squared minus 4 equals 0. Okay. Once we get the x prime and the x prime y prime terms out of there, we now have something that looks more familiar like what we had yesterday. Okay, let's go back up to the beginning. What type of conic is this supposed to be? A hyperbola. So we need to get this into standard form. Lucky for us, do we have to complete the square? We don't, because there's not an x prime term or a y prime term. We only have the squared terms. Woohoo! All right. So we don't like this 4 over here though, so we're going to put that on the other side. So we have 1/2 x prime squared minus 1/2 y prime squared equals 4. Right. Then to get this into standard form, what number should this be right here?
1.
A 1. So we need to divide by 4. And as I divide by 4, I'm going to rewrite this a little bit. We don't want to write 1/8 x prime squared. We want to write x prime squared over 8. Right? Minus y prime squared over 8 equals 1. And there is our hyperbola. Okay? So what did we just do? Okay? We took our equation, we figured out what angle we're rotating it by, and so then this is our graph. If we imagine that like on the XY axis, but then rotated 45 degrees. Okay, so it's the same graph as this, but rotated 45 degrees. And I don't want to worry about the graph right now. We'll come back to this after a while and graph it. But that's what's happening here. Yes.
So the prime just means like it's rotating?
Right. So we're basically going to draw a new set of axes based on our angle of rotation. And so that's where we would graph this as on our new set of axes. Okay, so we're going to have the x-axis and the y-axis, and then we're going to draw the x prime axis and the y prime axis. Would it help if we just did that right now? Okay, we have a block schedule, we can do what we want, right? We have so much time. Okay, so here's what's happening. Here's our y-axis, and here's our x-axis. We rotated this conic at what kind of an angle? Pi over 4. So pi over 4 is about right there. Do you agree? Does that look about like pi over 4? So that's going to become our x prime axis. And this will be our y prime axis. So now, if it helps you, I can't physically do this, but if you want to turn your paper so that the x prime and y prime are up, down, straight across, it may help as you graph this. But essentially, we're going to graph everything just on the x prime, y prime axis. So, in this hyperbola, what's our center?
0, 0.
Okay. Our center is 0, 0. Our a value is, or a squared is 8. So a is radical 8 or 2 radical 2. So radical 8, that's almost 3. You agree? Our b value is the same. So if we look at our rectangle, here are our asymptotes through our rectangle's diagonals. And then here is our hyperbola. Okay? So if we look at it and like concentrate on the x and y axis, it's a hyperbola that's tilted, right? If we concentrate on the red x prime and y prime axis, like that's what we graphed it on. Okay.
How do we know to draw them that way and like not on the other side of the rectangle?
Because since the x prime came first, we knew it was horizontal on our x prime, y prime plane. Oh, was that your question? Okay. Okay. So this is what we're going to do. We're going to take a problem from your homework, and we're going to go step by step where we're going to, you guys are going to work on one step, and then we're going to talk about it on the board. And then you're going to work on one step, and then we're going to talk about it on the board. So we're going to get through an entire homework problem, but you're going to do it, but then we're going to make sure you're right as we go through the process. Okay? So I'm going to pause this.